Hey y'all, so I basically forgot to record the first half of the meeting. Good thing someone in Zoom reminded me of it. So unfortunately, I forgot to record like the first 30 minutes of lecture or the first half. So I'm gonna go back right now after class since everybody left. Gonna re-go over the lecture, the first half of the lecture, and then yeah, this is gonna be split into two parts. So this is the first part, and then the second part I already recorded because it was halfway through the other half of the lecture. So yeah, sorry about that, but hopefully this makes sense. So basically, lab one was due today. A lot of people have requested extensions for it, so we're gonna have to extend it to Monday just because I know everybody's busy and everybody else, is going through a lot of stuff as students. We're all going through stuff, so we'll extend it to Monday. I'll send an announcement about that. Quiz 8 is released tonight, and we have three more things in our agenda. We have developer tools, we have deployment, and then we have accessible code. So you can kind of think of this as like the first half of the lecture, the part where I forgot to record is like the lecture 8 side of things, and then the part where I did record is lecture 9 side of things. So hopefully that makes sense, and let me get straight into it, and feel free to shoot me an email if things aren't clear. But yeah, so the entire topic of developer tools and deployment accessible code, basically in the industry, in software development, you have you have big teams, right? And you're looking to develop an application and make sure that everything is all up to scale. You have a whole process for doing have a lot of cool developer tools that'll help you do that. So we'll get into that. But to begin, what are developer tools? Developer tools are essentially programs that help developers create, test, and debug software. So this is anything ranging from version control systems to integrated development environments. Remember Git from our first lecture? Git was a system of version control that you can use to kind of merge and control your code. And then IntelliJ is the IDE side of developing tools. So an IDE is an integrated development environment. It's just a place where you can run, compile, and debug your code. So yeah, developer tools are a very broad range of tools. You can kind of it's kind of like a jack of all trades, but they ultimately all help you as a software developer in implementing code and debugging code and testing code. So the first thing I want to talk about is something called OpenJDK. So what exactly is OpenJDK? You might have seen it, you might not have. Basically, when you download Java, let's say you were in 61B and they told you to download Java onto your Mac or your computer, right? What you're downloading is not necessarily just Java. You're downloading all the things that actually need to run Java on your computer as well. So that's what OpenJDK is. It's a development kit, and it's also open source, but we'll get into that later. OpenJDK is what you actually download when you look up download Java, because Java itself is a programming language, but your computer doesn't necessarily know how to interpret that coding language. So there's something called Java OpenJDK, which has a virtual machine inside of it to kind of interpret Java. So basically any computer can download OpenJDK and run Java, and it would all be good. You don't have to necessarily have a Mac, Linux system, or a Windows system. What happens when you run Java essentially is you have Java itself as the programming language. It gets converted into bytecode or machine language. Basically, bytecode is instructions telling your computer what to do. And then this bytecode is sent to the Java virtual machine, which exists inside the development kit. The Java virtual machine, remember, it's a way of knowing what to do with Java commands or Java code. Your computer doesn't know how to do it. So Java virtual machine is there to interpret your Java code. And after it interprets it, it gives you an output. So yeah, Java development kit handles this entire process for you, and it's open source. And then to also summarize, the reason why we need development kits is because every computer is different and not every computer knows what Java is. Therefore, OpenJDK has a Java interpreter or a Java virtual machine that knows what Java actually is and will process it for you. So that is OpenJDK. Now, why did I talk about OpenJDK and why is it relevant? Well, OpenJDK is a open source Java development kit, but Amazon has its own spin on OpenJDK. So because OpenJDK is open source, that means anybody in the software development community can kind of contribute to Java and the development of Java and its associated virtual machine, etc. Amazon in the past has done a lot of open source contributions to OpenJDK. There's a lot of teams that are frequently making contributions in the community. But here's the thing, not all contributions in OpenJDK make it to the final cut. OpenJDK gets updates every 6 months. So every 6 months, there's a set of updates that are made to the development kit and to Java. And not all the updates or contributions made by the community make the cut. Well, that's not necessarily like optimal, right? Because there might be good ideas and might be good optimizations that aren't made to the final cut and not everybody can use. That's the problem. And Amazon realizes that a lot of the contributions they made are actually really useful for cloud computing, right? But they don't want us to let it go to waste by not letting it make the final cut in OpenJDK. So Amazon developed Amazon Corretto, which is like a derivative of OpenJDK. It's still Java. It still has a Java virtual machine, but it has all the updates that Amazon thought were useful that didn't make it to OpenJDK, but kept it into Corretto. So, and then Amazon Corretto also doesn't update every 6 months like OpenJDK. It constantly updates, and there's always performance enhancements for cloud computing, and it's free to use. So to summarize, Amazon Corretto is a style or a dialect of OpenJDK. It does the same things. You as a user won't know the difference between the two, but there's small distinguishments and nuances in Corretto that make it different and sometimes better depending on your use than OpenJDK. So let's say you want to download Java. You don't necessarily have to download OpenJDK. You can actually download Amazon Corretto and you have another version of Java, but it still works the same as Java. You won't know the difference as a software developer. But Amazon Corretto is there for you to have that alternative. And it's free to use. So yeah, it's marked by this like gnome penguin thingy, but that's the OpenJDK logo. But now with Amazon or AWS attached to it, now it's Amazon Corretto. So yeah. Next, we have AWS Cloud 9. So this is Amazon's integrated development environment. Remember IntelliJ from our first lectures demo? IntelliJ is the place where you run, compile, and debug code. AWS Cloud 9 is Amazon's version of an IDE. It's cloud-based, so you can run, write, and debug code in a browser, and you can test and debug AWS services too, such as AWS Lambda. And it's also free to use. So the reason why AWS Cloud 9 is so effective is because it's browser-based. It's in the cloud. This is really effective because when you have traditional IDEs that are downloaded to your computer, right? You're downloading the software to your computer, but you can only access that software and your code in that computer. So like if you, let's say, have a project in 61B that you developed in IntelliJ, and then all of a sudden your computer breaks, oh no, you just lost all of your access to the IDE and all the code. Now, what do? Well, if you would have to go and download Cloud 9, or you would have to download IntelliJ on another computer, pull from the Git repository to see all your code that you've written, and then start developing again. but that's like a pretty long process, right? You're downloading something again, you're, re-importing code, things like that. AWS Cloud9 is really effective. Let's say you wrote your entire project in Cloud9, and then let's say your computer breaks. That's fine. You can go to the computer lab or borrow your friend's computer, open up AWS Cloud9, log into your account, and boom, all your code is exactly where you want it to be. And you didn't have to install anything. It was all in the cloud. So that's why AWS Cloud9 is so effective. It has this feature. And then additionally, there's some other aspects of it. You can have multiple users access the same code terminal or the code editor, much like IntelliJ, but it's in the cloud and people within your AWS team can do it. So yeah, AWS Cloud9. The next thing I want to talk about, stepping aside from text editors, integrated development environments, we have shells and command line interfaces. So these are kind of like concepts you might have seen in class when you're introducing command line interfacing and command line programming. Basically, there's two big things that work together. You have something called the shell and then a CLI, or a command line interface. A shell is essentially a program that's installed on your computer that processes terminal inputs, or like a command input. So to give an example, in Mac, right, when you type in CD and then you type in a directory, you're changing to the directory, right? And you wrote that in your command line interface terminal. How did it actually know what you were trying to do? Well, your shell interpreted your command and then just did the associated function with it. So the shell understood, okay, CD, that command means change directory. I'm going to do that now. So yeah, shell is the interpreter and the command line interface is the place in which you write the commands. So in Microsoft, you have the bash shell. This is the default shell that Microsoft likes to use and licenses under. And then the shell runs in the command line interface of command prompt in Windows. So when you're typing in command prompt, you're interacting with a command line interface with the associated shell of bash. In Mac OS, it's different. Mac OS licenses the ZSH shell, and the command line interfaces associated with Mac OS is terminal. So if I type in terminal and then type some CD command, I'm using terminal as the command line interface, and the shell ZSH is processing that command. So that is a brief overview of shells and CLIs. So why did we talk about shells and CLIs? Well, guess what? Amazon has their own spin on that. So Amazon has a cloud shell. Basically, it's a browser-based shell used for the Amazon command line interface. It's automatically installed with every AWS account, and you can use commands to create EC2 instances, connect to databases, run applications, etc. And it's free. So in every AWS account, it's synonymous with like the terminal on Mac or the command prompt on Windows. You have the AWS CLI, which you see right here. And then when you type in a command such as like trigger a Lambda function, the cloud shell interprets that and does the associated function. And you can find this command line in every single AWS account. So that is really cool. So yeah, AWS has gotten into the shell market and has made their own spin on that. Next, we have three separate concepts. We have libraries, packages, and artifacts. These are terms that are sometimes used interchangeably, but there's strong distinguishments between them that we want to really emphasize. And you'll see these words used a lot in the industry. But what a library is it's a set of programming code that is used for software development. So if you know NumPy or Pandas from class, these are Python libraries, right? They're not necessarily Python itself, but they're libraries created by people to perform something using Python code. So a library is a set of code that allows you to perform some functions that aren't traditionally performed using traditional code. So in this case, NumPy has a lot of arithmetic operations that it can do that wasn't originally created by the Python programming language. And Pandas is like a data science kind of library in Python. So yeah, that is a library. Library, you can think of it as just a set of tools or a set of programming code that are slight derivatives of the original programming language. Next, you have packages. Packages are just a unit of distribution when you're trying to send your software over to different people. You know, when you download Spotify on Mac, or when you're downloading Google Chrome, etc., you're downloading packages from wherever the source is. So from Google or whatever. If you're downloading Google Chrome, you're downloading from Google. Google sends you a package. With the package, there's an installer, and the installer takes those packages, basically unwraps them, does all the essential building scripts, and then boom, now you have Google Chrome, or now you have Spotify. So package is just a unit of distribution. And when you're sending software over to different people, you send them in packages. And then those packages work together to create the entire application when they are unwrapped. And then artifact, this is essentially just any sort of byproduct of software development. So this includes source code, testing, and QA. It includes like the goal of a software development team. It includes like feedback from the QA team. So it doesn't have to be just code or software development related. It can be like an architectural diagram of your stack in a full stack team. It's just anything that represents the work you're doing in a software development environment. That is an artifact. So this includes code, but it's not only exclusive to code. It includes anything that's related to what you're doing. So those are artifacts. Artifacts encompass a large range of things within software development. But traditionally, and it's important to note, traditionally, when you refer to artifacts, you're referring to code. You're referring to code in the form of an artifact. So when you say I'm pulling an artifact from the repository, you're most likely saying, oh, I'm pulling a file or a piece of code from the repository. Cool. So remember, artifacts are anything related to code or anything related to a software development team's progress or like a byproduct. So code artifact is essentially a storage/repository service for pulling and sharing those kinds of packages across teams or organizations. So with code artifact, you can have code that has been developed by a software development team in a certain branch, and then another team can pull from that repository and get the associated artifact that they need for development, and vice versa. So it's effective when you're developing applications that require a lot of dependencies. So for example, if I had a team that created like a date and time library that they created on their own, and so in the team they created it on their own, and when another team creates some feature of an application that requires that library, the date time library, they can use code artifact to implement that dependency into their features. So for example, once you create the library that uses datetime or creates datetime, you can upload the datetime library to code artifact, and then the team that requires the datetime library can pull from code artifact and then use it to deploy their features or their side of applications. And then all you have to do is pay for storage size, and you pay by request count. So essentially, it's like a repository, but for artifacts. So to kind of visualize it, you have public repositories. Oh, this is another thing about code artifact as well, is that you can pull artifacts from public repositories. So like libraries like NumPy or things like that, you can pull them much like importing in Python, you can pull them from public repositories and use them as well. But basically, if you wanted to pull from a public artifact repository, you pull it into code artifact, and then you can kind of send it over to your developers when your developers need them. So the developers can pull application dependencies, and then we can also use artifacts in deployment, or in code building, which is something else we'll get into in a minute. But essentially, code artifact manages artifacts, and you're able to use the artifacts for building code or sharing it across teams. Cool. We're going to take a quick break. Or actually, for the sake of this video, you can take a 5-minute break, but I'm going to speed through it since we already did take our break. So the next topic I want to get into, and it's not necessarily related to like the first part of what we just talked about, CI/CD. This stands for continuous integration and continuous development. This is a software development practice that helps teams release features and test features while maintaining like a live version of their application. So, like for example, in this lecture, we're going to be using a social media app as a prime example. But for example, Instagram, right? Instagram is always live. Like users can download Instagram and always use it, even though Facebook or Meta or the Instagram team is constantly building new features. How is this done? Well, they use a CI/CD pipeline or a practice or a process to kind of make sure that everything runs smoothly. So basically, whenever there's a new feature and you want to release it, we follow a CI/CD pipeline. So I'll get into an example, but this is kind of like an outline of what that looks like. You have a release of a feature, you deploy it, you check the operation, monitor it, and then you get feedback from it. You developed a new plan, code it, you build it, and then you test it and then release. So it's just a constant cycle of continuous development and continuous deployment. So an example, say I work at a front-end team in a social media app company. So say I work at the front-end team on Instagram. To illustrate, the CI side of my scenario is whenever my team develops new code, the code needs to be merged with my team develops new code, you need to integrate it with the other team's code. That's where the continuous integration aspect of things comes into play. You're continuously integrating with other teams' pieces, moving pieces in your entire application. So that's continuous integration. When you're developing new code, you need to make sure it's integrated with all of the other teams. And then you have continuous deployment. Basically, when this code is deployed, you need to make sure it is tested in the testing environment. And after it's tested in the testing environment, it's deployed to live. So when I create a new feature, I want to test it out. Once it's tested and it's fully functional and passes all the checkboxes, or checks all the checkboxes, now you can push it to live, and now all the customers can see the new feature. And a good analogy is to think of it as car manufacturing. In CI, you develop the car, you develop the frame of the car, you develop the wheels, you develop all of that. And then once you're developing it, after you finish developing the whole car, you send it over to a testing area to deploy it, or to use a test dummy to make sure it passes all the standards for vehicles. So to think of it, this analogy, CI is the building of the car, and CD is shipping it out to the respective areas for testing and deployment. So testing with the crash dummy, and then once you know it passes all the checks, you can deploy it to live. Or in other words, you can now put the car on the market, and now it's free for everybody to use. Or not free, but it's free for everybody to look at and to buy. So car manufacturing is a great example of a CI/CD pipeline in an analogous sense. So to speed up a CI/CD process, Amazon has a great service called Code Build. It's a CI process, CI service. Basically, Code Build compiles your code, runs tests on the code, and produces packages that are ready to deploy. So build scripts, it runs build scripts and builds build scripts. So whenever you push a new piece of code, there's sometimes conditions that you need to make sure the code follows in your environment. Once that code passes all the checks, it produces build scripts or packages ready to deploy. So let's say there's a new feature at Spotify, and after you develop it and you create a package for the Spotify installer, that essentially is something that's a part of the build script. So when you're downloading Spotify and using the installer is running your build scripts. It's running the process that actually builds the Spotify application. And that's something that Code Build handles. It helps you bundle all your code up into a build script package. And then that package can now be sent to users. And then you just pay as you go for build times. So Code Build, you can think of as the assembly line in the car manufacturing analogy. All the pieces are put together, put into packages or cars, and now you're shipping the cars out to deployments. So yeah, AWS Code Build, it's a CI service. Now you have AWS Code Commit. Basically, Code Commit is not necessarily a CI/CD service in terms of like CI/CD being one of the categories that this falls in. Code Commit is just a tool that helps CI/CD environments. So Code Commit is essentially a private version of GitHub that Amazon has created. You can have repositories of up to 25,000. And it has a lot of the basic GitHub features like pulling, pushing, blah, blah, blah. But it also has access management, and you can integrate it with other services. So other services can pull from these repositories. And you pay 1 month per active user after 5 active users. So when you think about it, Code Commit is just Amazon's version of a private repository. The reason why private repositories might be useful is because you don't want people to see your code publicly, and you want people in your AWS environment to view your code. You can set up permissions for who can see what, and that all can be done in Code Commit. To kind of visualize it, you have the same processes. You can create a pull request. It has a really nice Amazon style UI. You see, you can write a title for why you want to create this pull request. And then in your commits visualizer, you can see the same things as you would in GitHub. For example, merged. This description is added another file, add another testing of editing features. This can also all be handled by AWS Code Commit. So yeah, it's a great tool that software developers use in the cloud. Okay, and I believe this is the part where I realized I needed to record. So I'm gonna go ahead and end this recording now, merge it with the next recording. So, all right, thank you guys, and sorry about the confusion. Okay, for those of you who just joined in on this recording, I forgot to hit record at the beginning of the lecture. So after I'm finished with this side, I'll give a timestamp of when to start the recording. But thank you for the reminder. So Code Deploy is a CD service. Basically, you deploy your updated applications or artifacts to various environments or deployments. So you can deploy it to EC2, ECS, Lambda, Fargate, etc. So like those are your different deployment areas. And then you pay for only the updates to the on-prem environments. So remember, on-prem is like when you have hardware that you own and you don't have it in the cloud. You just basically pay for the artifacts or packages that you deploy on-prem. But when you're deploying to EC2, for example, it's all free. So yeah, AWS Code Deploy, if you look at this visual, you have like a dev team that pushes to GitHub or code commit. You can trigger a code deployment. So as soon as it does all the right checks in GitHub, you have a code deploy phase that deploys the nice and updated source code into an EC2 instance. And that's like a new update to your application. So yeah, code deploy, CD service. An example of code deploy. So imagine you're working at Instagram and Instagram Reels was just deployed. And all of a sudden, Instagram just crashes. Like all the users who just downloaded this new feature, it just completely fails. Like you load it and then you get errors. Code deploy actually has this nice rollback feature or reverse feature that allows you to restore your application to previous states. So you can actually use code deploy to do some sort of version control in a sense. You can make sure your code deploy environment is always at the stage in which it is usable by your current users. So code deploy has some nice quality checks that it makes sure you maintain a healthy environment that's always usable by all your customers. So yeah, so Instagram Reels, if it didn't happen to work out, you can revert it to an Instagram without Instagram Reels and try to fix the bug later. Yeah, so that's an example of code deploy. Nice. So we have code deploy, we have code build. Now we're going to talk about the code pipeline, AWS code pipeline. So you can actually automate the entire CI/CD pipeline. Basically, what that means is you can set up a workflow to maintain the whole process from the source to production. So CI/CD, right? It's a pipeline. AWS has a way to integrate code deploy and code build all into one piece and then automate the entire process. So there's a visual on the next slide that you can look at. It'll help you contextualize it, but you can get one free pipeline per month, and basically it'll automate the entire process of CI/CD. So you have source, you have like source code, for example. Once you build it, you want to test it, right? And after you test it, you want to stage it in the correct environments. And then once you know that it's in the correct environments, you can deploy it or produce it. So putting it all together, you have AWS code pipeline. That's like the orchestrator or like the overview service. And then in individual services within code pipeline, AWS code pipeline manages each of them and makes sure they're all automated in this entire process. So let's say you have source code in code commit. Once you push code to code commit and then it, passes the correct checks and it triggers, you can build the code. Once the code is built, you can test it. And after the testing is done, you can produce it / deploy it using code deploy. So this is an entire CI/CD pipeline, right? You create a new feature, you build it, put it into packages, you put it into the right environments, and you release it to the public. And code pipeline is essentially the orchestrator or the manager that makes sure that these all run in sync and it's automated and that you don't have to do any of the micromanaging and taking this code and testing it here and then doing this here, blah, blah, blah. This will take all of that and transport every single process smoothly. And then testing is usually done using third parties because AWS actually doesn't have a very general testing tool to use because testing comes in a lot of different forms in certain teams. But yeah, this is the overview. So to give an example, along with that visual, you wrote a code for the add function, right? Add X and Y. You push this code to code commit. Okay, now your source code or your add XY function is now in code commit. Now you want to create a package, right? With that code from code commit, you can build it into code build. And then afterwards, you want to test it on some test cases, let's say I want to do add 1 + 1 = 2, test that, add 2 + 2 = 4, test that. You can do that with third-party unit testing. And then afterwards, you know that it's all good. You can use code deploy to deploy your add XY function to Lambda, right? Because you can use code deploy to send over your packages to any AWS service or your on-prem services. So you can send the add X, Y function to Lambda, and boom, you just went through a whole cloud pipeline process of CI/CD. You have code, created a package for it, tested it, and you sent it to a different AWS service. So to kind of visualize it here, this is what's stored in code commit. You wrote it out. You're sending it through the pipeline. So you build it, test it, produce it, and then you ship it out to AWS Lambda. And then the shipping, all that building part is orchestrated by AWS code pipeline. So yeah, this is the big picture, right? The whole spiel. You have this big sandwich of services that you've all integrated with code pipeline. So that is CI/CD in the cloud. The last service we're going to talk about is CodeStar. So you know how code pipeline, right? You kind of have like a lot of processes going on. You have like deployment phases, you have integration phases. It's very confusing, and when you're working in a small team, you don't necessarily know how to orchestrate that entire process very quickly. It's not very intuitive, right? You're like, what is code build? What is code commit? Like, how do these all work in sync? Well, CodeStar is like a nice and friendly service that you can use to do an actual code pipeline process. So it's an easy to use and quick application development tool, and it's very free. So it's really nice to use. And I'll give it, this is actually the final part of our lecture. I'm going to be demoing kind of what CodeStar looks like. But basically, CodeStar is like an easy way to run a CI/CD pipeline, and you can follow templates. So let me show you what I mean by that. I'm going to exit out of my slides. Actually, I have a visual for you. So this is another visual demo. So let's say in this demo, I have a scenario or a case study. I want to create a website for my personal project, like a really easy, simple to do website. I have no knowledge of code pipelines or code pipeline. I have no knowledge of a CI/CD process. I don't know how anything works. You don't want to spend too much time developing it. I want a nice UI for development. Let's say I know React, I know HTML, but I don't know how to actually put them all together. And I don't want to learn about many AWS services. I just want to create a personal website really quickly and not learn a lot of stuff in the process. This sounds like a perfect scenario for CodeStar. So moving out of the slides, oops, hopefully you guys don't quickly scan that really quick. Okay, so we go AWS CodeStar. Not the logo, excuse me. So sign in. We can go to AWS CodeStar. So I've actually, because CodeStar takes a little bit to get up and running, but basically what you would do, you can kind of read the outline. It allows you to quickly develop applications. You can create a project right here. And what CodeStar does is you have different types of templates that you can follow and different languages that you want to do depending on your application. So let's say I want to do a website and I want to make it in React, or actually in Node. Let's do Node. You can select Node, and then you see the application type is a web app / website. You can do that. It has AWS Lambda integrated within it. You can create your project. So my personal website, Remember code commit, right? You can use code commit to store all your repository information. You can use that, or you can use GitHub. But let's say I want to use code commit, and I call my repository my personal website. you have the application template. The framework is Node.js. You want to create a web app. And the default service that they use to handle a lot of the processes is AWS Lambda. Let's set up my project and let's create it. So for the sake of time, creating the project actually takes quite a bit, but I already have a project created to show you. So we'll just go to CodeStar. Let's say this is because I'm in Oregon, right? Yeah, it's cool because edge locations have different like information about your stuff. So this is like, let's say I just hit create. Now I have a simple website. See, you can set up Cloud9, you can set up other IDEs when you want to develop, but basically this is your website, and CodeStar literally just did the entire CI/CD pipeline for you, or set up the integrations for the CI/CD pipeline. So you have the IAM, you have the pipeline that controls code deploy, code commit, code build, has your information stored in S3. So every CodeStar project template has like a README that tells you what's going on. But basically, remember I said I just want to create a simple website, right? But I don't want to spend that much time developing it. I don't know how to do it. CodeStar literally just did it for you. Look, you hit view application. Congrats. You just created a Node.js web app. So this is a fully functional website. And CodeStar just abstracted half the development process for you. Now all you have to do is just go to the respective repositories or the respective areas where the code is actually created. You can edit it and input your own Node.js or React or HTML elements, and boom, you can create a whole website from scratch. Like, for example, you click home and it'll navigate you to a certain thing. That's something that was already created by AWS. So yeah, and then it has code pipeline it's already installed. So when your application or web app is deployed to live, you can immediately just use the code pipeline to push new features and make sure it's developed correctly and pushed to the right environments correctly. So yeah, all these services right here you see in this list, they're already integrated within CodeStar. And now CodeStar has just created a whole website for you, and you didn't really even have to do much. Now all you have to do is just edit the code and change it up, make it your style, and then boom. Nice. You just have like a fully running website, and it's all hosted in AWS. And it's also free. Like, you can create one personal project and you can use that project. You can use that project for free. You only give one free project per month. But yeah, any other questions? This is actually the last part of our lecture. So questions are here for you, and you can have, another thing, you can have monitoring features. You can see who accesses your website. You can set that up. You can kind of see the status of your website too. But yeah, other than that, thank you all for coming. We have the attendance code here. The code is pipeline to represent and then cement to your head the CI/CD pipeline idea. But other than that, thank you all for showing up. I really appreciate it. And I'm going to have to spend some time going to the beginning to record the first part, but we got it. Thank you all for showing up. I'm actually also going to extend the Lab 1 deadline because some people have emailed. For those of you who have not done Lab 1, don't worry, it'll be due Monday now. But thanks for those of you who already turned it in.